Okay, let's go ahead and get started. We'll start with our first strand, data and information. So the way I'm going to go through these is I'll break it down in grade bands, K to 2, 3 to 5, and then 3 to 6. I'll go through the standards verbatim, and then what we'll do is kind of translate those into layman's terms, and then we'll talk about a few resources that you can use as a teacher, regardless of your comfort level, to start giving your students opportunities to engage in computer science education. So let's go ahead and get started. So in grades K to 2, DI1, data and information, Standard 1, use technology resources to solve age-appropriate problems and communicate thoughts, ideas, or stories in a step-by-step manner. DI2, understand how to arrange information into useful order, such as sorting students by birth date without using a computer. And DI3, recognize that software is created to control computer operations. Okay, so what does this all mean? It means basically don't keep the computers on the cart. Students will learn about the organizing of data and sequencing both on a device and off. They'll learn that software is what tells the computer what to do. So some activities that'll help students develop those understandings. CS Unplugged, which the link is down in the description, has some great resources to help students of all ages, but specifically our younger learners, understand computational thinking in a hands-off manner. So it's very developmentally appropriate. Code.org also has some awesome resources for teachers and students to use to help develop that foundational understanding of computer science. And then really any kind of desktop publishing you can do with kids. Any opportunity you have to have them use something like Google Docs or Google Draw or Google Slides or Google Sheets, like having them actually go in and create evidence that demonstrates sequential thinking or step-by-step thinking. Desktop publishing really lends itself to that. So now let's switch gears and talk about our 3rd to 5th graders. Their DI1 is to understand and use the basic steps in algorithmic problem solving. We'll see these steps again later, but really that process is identifying the problem, so problem statement, exploration, examination of sample instances, design, implementation, and testing. That's algorithmic thinking, okay? And then DI2 is to develop a simple understanding of an algorithm. So search, sequence of events, sorting, using computer-free exercises. DI3, demonstrate how a string of bits can be used to represent alphanumeric information and how ones and zeros represent information. DI4, describe how a simulation can be used to solve a problem. DI5, understand the connections between computer science and other fields. So what does this mean for our 3rd to 5th graders? Steps, understanding and learning the steps of solving problems using technology as well as unplugging and using unplugged learning activities. Really developing an understanding about how computers think and then the role that computer science plays in the world. So how different industries and different parts of the economy are so dependent on technology. All right, great resources in CS Unplugged and also code.org for these groups of students as well. Now we'll kind of grow up a little bit, and here we go into the middle school world. DI1 for grades 6 to 8, use the basic steps in algorithmic problem solving to design solutions. So that process before, problem statement exploration, examination of a sample instance, design, implementation of a solution, testing, and now evaluation. DI2 described the process of parallelization as it relates to problem solving. Represent data in a variety of ways, so text, sounds, pictures, and numbers, and use different visual representations of problems, structures, and data like graphs and charts, network diagrams, and flowcharts. DI4, understand the notion of hierarchy and abstraction in computing, including high-level languages, translation, instruction sets, and logic circuits. DI5, demonstrate interdisciplinary applications of computational thinking and interact with content-specific models and simulations to support learning and research. That's a lot to unpack, but what it basically means is that students will develop an understanding that computers break up tasks into smaller pieces. They need to understand that certain conditions need to be met in order for programs to work. Showing how this process of thinking works through the process and how that applies to other subject areas. So much higher level, much more focused, but the CS Unplugged and the code.org curriculum are going to be great resources for even our grades 6 through 8. So this is definitely, without a doubt, the most overwhelming and intimidating aspect of computer science instruction for most teachers. Rest assured, the more you teach it, the more you expose students to this type of process-oriented thinking, the more you'll understand it and find cross-curricular applications and benefits. If you have other resources that you can recommend to help students of grades K through 8 develop that real computational and algorithmic thinking, do me a favor, drop them down in the comments below. We'd all love to learn together and learn from each other. So thanks for stopping in for this first video. I look forward to talking to you about the next strand of the Indiana Computer Science Standards.